Alright, ladies and gentlemen. In this video, we're going to talk a little bit about what it is that makes different atoms different. So hopefully you realize by now that this chart in front of you is the periodic table of elements. And that is a key term that we have here, is this idea of elements. And elements are basically different versions of atoms. Now, atoms are the smallest unit of material in the universe that maintains its properties. Now, this is important because you need to understand that you have atoms. Everything in the universe is made of atoms. But the atoms that things are made of can be different. And so what we need to talk about now, as we start our discussion of atomic theory, is what is it that makes atoms different? I think it's fair that all of you could say that sulfur, right here, is different than hydrogen. Sulfur is an atom. Hydrogen is an atom. But they are different elements. So the question that we need to answer in this presentation is, what makes them different? And to do that, we need to take a closer look at the internal structures within an atom. So here what we have is a very simple diagram of an atom. All right, now it's actually not, it's a form of one atom, but it's not necessarily important that we think about what atom this is, but rather simply that we think about it as an atom. All right. So what you have here is the three basic, what we refer to them as, are subatomic particles. Okay? Now the subatomic particles are protons, neutrons, and electrons. And that's it. Every element is made of protons, neutrons, and electrons. What makes hydrogen different than sulfur is how many protons, how many neutrons, how many electrons. And so what we need to do to really see how that difference comes about is to look at what makes protons, neutrons, and electrons unique. So protons all have a mass of 1. Now, we use something called an atomic mass unit. All right? Atomic mass unit to measure the mass of these subatomic particles, because they are so small that the normal units don't work. Like, we can't use grams, and we can add as many prefixes as we want, but it just gets so small it's unwieldy. So we've created this unit called atomic mass unit. And what you'll notice is that a proton has 1 atomic mass unit, and so does a neutron. So it's convenient that we based the atomic mass unit off of the proton and neutron together. The proton has a charge of plus, so it has a positive charge, and the proton can be found in the nucleus of an atom. Now, neutrons also have a mass of 1. They are also found in the nucleus of an atom. But what makes protons and neutrons different is that protons are positively charged and neutrons are neutral. Neutron, neutral. Proton, positive. But both of those are found in the nucleus of an atom. And that's very important because atoms always have 2 locations. All right. The first location is the nucleus. And the nucleus is an absurdly tiny thing. If you were to think about an atom as a football stadium, all right, the nucleus is a pushpin on the 50-yard line. And the electron cloud, which is what makes up the rest of the atom, is the rest of the stadium. Okay? The nucleus is very, very tiny. And the electron cloud is mostly empty space. What it is filled with is electrons, and how many electrons depends on the element. And electrons have a negative charge. Okay, so right here you can see they have a negative charge. Electrons are orbiting the nucleus in this cloud right here. And electrons have an effective mass of 0. They do have mass, but the mass is so ridiculously small that we effectively refer to it as 0. All right? So protons have a mass of 1, a positive charge, and are in the nucleus. Neutrons have a mass of 1, no charge, and are in the nucleus. Electrons have a functional mass of 0, a negative charge, and are outside the nucleus, orbiting the nucleus. All right? These three pieces, protons, neutrons, and electrons, make up every single atom. And what makes the atoms different, okay, what gives us our elements is different numbers of protons. All right. Specifically, it's the protons that give us the different elements. But if you have a different number of electrons and a different number of neutrons, what you get are different properties. And we know how important properties are when it comes to interacting with the physical world. All right. So it's actually the protons, the neutrons, and the electrons in varying combinations that give us all of the elements that make up the universe. Right here, we have an element of helium. And I just want you to get a sense of what a real element looks like. This gray box right here is currently representing the nucleus. And you'll notice that what you find in the nucleus are the neutrons and the protons. You'll notice the protons have positive charges and the neutrons have no charge. You'll notice that here, outside the nucleus, we have our electrons. Okay, see that right here. And you'll notice that they're put in these two spots, but they're not necessarily there. They're actually constantly in motion. Okay, and they're just sort of running around the outside of the nucleus. And the electrons, you can even see in this diagram, take up a lot more space. They're out, like the nucleus is a small, concentrated, everything's like really small inside of it. But the electrons are like flying wildly around it. You also can see how small the electrons are compared to the neutrons and protons. All right? And this is a basic diagram. You could do this for any element on the periodic table. And we will get to the point where we do these for various elements. But for right now, I just need you to understand the basics of what we're looking for. Okay? Now, the last thing that we want to do in this video is talk about how diagrams like this translate to the periodic table. So here you have a standard block on the periodic table. And this right here is our element symbol. In this case, Hg, hopefully you remember, is mercury. Okay. Up here, we have the atomic number. Now, the atomic number tells us several things about the element. It tells us how many protons it has. Now, the atomic number is the single most important thing on the periodic table because it is the atomic number that differentiates different elements. Mercury is the only thing with an atomic number of 80. Hydrogen is the only thing with an atomic number of 1. Oxygen is the only thing with an atomic number of 8. Carbon is the only thing with the atomic number of 6. The atomic number is what differentiates one element from the other. Now, typically, the atomic number also will tell you the starting number of electrons. Now, it's important. I use this word starting because we're going to talk about the things we can change within an element, and we can change the number of electrons. So it's important that you understand that the atomic number gives you the number of electrons an element will begin with. What happens after that depends on a lot of other things. But the atomic number here tells us the protons and the electrons. Now, down here at the bottom, you'll notice we have a different number. And the thing here about this number is it's a decimal. And this is how you can always tell the numbers apart. On a periodic table, there will always be, within the block, the atomic number, which is always a whole number, no decimals. The symbol, which is just letters. And then this number down here, which will almost always have decimals, and that is the mass number. Now, we're going to get into why it has decimals in another presentation. But in general, when you are working with the mass number, you are going to round. So here I have 200.59, so I would round that, in this case, to 201. Because I am rounding to the nearest whole number. Okay? Now, you'll notice over here, I told you that protons have a mass of 1, and neutrons have a mass of 1, electrons have a mass of 0. So the mass number is literally nothing more than just the mass of everything in the element. The thing is, the electrons have no mass. So the mass number is really just the protons and the neutrons. So in this case, I know that the protons are 80 because of the atomic number. So I know that I have 80. I don't know how many neutrons, but I know the mass number functionally is 201. And so 80 plus n gives me 201. So that means that n, which is the number of neutrons, is 121. So what's important to understand is every key piece of information that you need, you can get from one of these blocks in the periodic table. All right, those are the basics of atomic structure.